Let's proceed further. MSA, kindly continue.
MSA, Measurement Systems Analysis, is a tool for analyzing the variation present in each type of inspection, measurement, and test equipment. In other words, it's allow us to make sure that the variation in our measurement is minimal compared to the variation in our process. Measurement System Analysis, MSA, is an experimental and mathematical method of determining how much the variation within the measurement process contributes to overall process variability. Measurement is the key and essential in Six Sigma, as it determines how strong or weak an effect each individual measurement has on a larger system.
See, as simple as such, measurement system, any kind of measurement. For example, take your tool, your weighing machine. Okay. Weighing machine will be having a different way. Everybody, you have a different, the weights, right? And the weighing machine, okay, the weighing machine, when they have a variation, for example, when they're changing, for example, if you're standing as a father and you have a child there, when you're changing the scaling with each other, you'll see the variation in the scales, correct? And that variation would be that variation needs to be understand the reason of variation. I can tell you this second. So it's a tool, any tool which shows a variation, all right, like weighing scale, weather, climate, temperature, simple. What is it showing? Two different people have two different variation present. When and how do we get this? From inspection, measuring, testing the equipment. In simple word, it is helping us to understand what is a variation in the measurement when you're comparing to the process. And it is, MS is nothing but it is an experimental and mathematical method. I repeat again, MSA results are defined. So the results are, not all the results are reliable because it is experimental. All right. Yes. Whenever it's experimental, you cannot be reliable on those results. So it is a mathematical method determining how the variation within the MSA contributes to the process variability. MSA is essential for the Six Sigma because it is showing us whether our solution, because we are working on the solution, correct? Whether a solution gonna be affecting the individual measurements on a larger scale. That means whether the solution would be applicable to the company or not. Got it? Okay. Whether our solution will be applicable to the company or not. Let's proceed further. Kindly continue.
Measurement system has an issue. We will receive inaccurate data. As a result, making decisions based on incorrect data will result in process or product failure. So, using statistical analysis and test, we examine the variation in the results of inspection, measurement, and testing equipment systems. As a result, measurement system analysis is defined as the base of determining variance in the process caused by the measurement system. Because measurement system analysis, MSA is a critical component of the product part approval process, PPAP.
PPAP. Anybody here? What is PPAP? Quickly. Okay, it's production part approval process. What is production part approval process? For example, okay, in a manufacturing industry, this MSA is a requirement tool. Let me take tires. Okay, let me take tires. Tires have different units, different bolts, nuts, correct? Rubbers,
yes,
correct? Right? Elasticity. Yes. So it has different units, correct? Which needs to be assembled. Yes or no? Correct? Which needs to be assembled.
Yes.
So PPAP means they are approving each unit before going to the assembly line. Got it?
Yes.
Got it? So they are approving each parts before assembling it in the final one. That is called as PPAP. Clear? And this MSA help us to understand whether the unit have a failure. If one unit have a failure, there's a probability the entire assembled product has a failure. Yes or no? That's why we have manufactured default. That's why we have manufacturing defaults. Correct? That's why PPAP becomes helpful. And to able to do the PPAP, MSA becomes helpful. Clear? So there are different types of MSA. The first one, bias study. Kindly continue.
Bias study. The deviation of the average observed average of measurement from the true value is defined as bias. Bias equal to observed average minus reference value.
Okay. So here it is bias study. That means deviation. This is something which you can tolerate. This is something which you cannot tolerate. That means average measurement from the true value is defined. For example, it could be any, bias means observed average minus reference value. So every particular, manufacturing industry, they have to refer a specs chart, correct? They have to refer to the
Yes.
evaluation chart, correct? So they have to see whether my observed data and my reference value from my evaluation chart are similar or can we subtract or not. Are we getting it? We try to balance. We're trying to understand.
Is it one type of variation, ma'am? From
Yes,
the
yes, it's a variation. Yes. All right. So it's what do you mean by this? This bias study is also called as accuracy in Gage R R. I'm going to tell you the connection between MSA and Gage R R, but it is an estimation of the error. What are we doing? MSA is giving the estimation of error. What could be the error, possibility errors we're trying to find out. So to find out the error in a larger scale, first try to find out the error in the first type, that is bias study. See, we get this spec chart. Based on the spec chart, we are just subtracting or able to balance the observed data. Understood? Clear? Okay. Next one.
Linearity study. The linearity of an instrument is defined as the difference between its bias and its intent operating range. Does your gauge have the same bias throughout its operation range? Linearity is equal to bias at higher minus bias at lower.
Exactly. So types of MSA. When we say this is first one we learned about simple bias study. And what was the example? How do we calculate the bias study? Anybody here?
We will do we do have some checklist.
Correct.
Some pre-approved checklist.
Pre-approved checklist.
Yes, and for example, in our industry, we for testing of any electrical equipment, we have a checklist, pre-approved checklist from our best industry practices. Correct. And we will test whether that value matches with the checklist. So if there is any variations, we'll find we will do some rectification.
Absolutely correct. Correct. And that's why you're trying to follow the false first. Rectification is the later part. We are just verifying and analyzing whether there is any kind of fault in the current unit. That's it. Clear? So linearity. The next one is linearity study. Linearity study is an instrument. Now they're taking an instrument where they understand the difference between the bias and intended operating. That means difference between, see, in the bias study, you're just getting the details. Okay. So if my range is 0 to 10, my observed data was 9 and my expected data was 10. So there's a difference of 1, correct? Yes. And the 1 would be reworked in the linearity study. Got it?
Yes.
And the linearity study will be now taking actions over that. Understood now? Okay.
Yes, yes.
Thank you. Next slide, please. Stability.
Stability. The change in bias over a long period of time is referred to as stability. As a result, the overall variance detected with a measurement system on the same master part over a long period of time.
Okay. So here's stability. Like for example, any particular production, they go to the multiple variation, correct? Any particular manufacturing industry goes to multiple variation. It is for those which has longer processes. Those particular processes which has a longer sets of parts, longer sets of periods to able to complete one cycle. All right. That's refers to stability. Stability means whether the overall variance detected with the MSA is the same on the same part for a longer period of time. It should be same in the time 1, same in the time 2, same in the time 3. What should be the same? The variations. All right. The variation. For example, converting the rubber into tires. All right. For converting rubber into tire, you require the similar sets of temperature, cooling effect. Otherwise, the tire would be considered as rejected. I'm just talking about the tire, not the nuts and bolts. Only the rubber to tire. The elasticity should be consistency. Otherwise, the entire unit or that processes would be marked as rejected. Clear?
Yes.
Next one. Gauge repeater.
The combined variance of repeatability and reproducibility is given by Gage R and R. This research was carried out using 2 methods, a range method, average and range method.
So gauge repeater, this is going to be a very big topic. R and R, Gage R and R. I'm going to study first. What is R and R? Repeatability and reproducibility. What is Gage R and R? Gage R and R or Gauge R and R, some of the pronunciation Gauge. This comes after R and R. R and R is completed in the next slide. First we'll complete the foundation, then we'll complete the advanced. Is that okay? I cannot go
Okay.
reverse version. I cannot
Yes,
go the
ma'am.
reverse version. It's going to be descending order. Let us go to the ascending order. So the ascending order, first complete the R&R, which is in the next slide, and then I'll just one slide. I'm just keeping on hold. I'm just keeping the slide. The 12 slide
Yes.
number 12 would be done in the after we complete the R&R foundation. Okay. Then moving further. Attribute MSA.
Attribute measurement study. Finally, attribute characteristics are those in which the measurement values are one of a finite set of characteristics or there are no measurement values. A go gauge or visual inspection is the most common example of an attribute measurement system.
See, go and no go. Go means giving a go to the unit. Fine, we are good to go. It is absolutely fitting up with the expected data, expected spec charts. All right. And no go means no, it's not working. You have to reject the slot. Simple. That's attribute measurement system. All right. So it's a visual inspection. What is it? You're visually
Visual
inspecting it.
inspection.
Yeah. It's when we saying visual inspecting, you're not just giving an authorization on the go or just, by taking up for example, if I have a line manager, he comes up to me and tell me, ma'am, we are done with for the day. And this is the submission of the final report. Kindly give the authorization for the final procurement. I will say, no, let me go back, take the visual inspection. I'll do the cross check by my own self. And then I'm going to go good to go. Got it now? Accuracy and precision. Kindly continue. So what is accuracy? In simple language, it's going to be a little bit general. General talking, accuracy means how accurate you're to the bullseye. Got it? You're accurate, but you're not precise. What do you mean precise? Precise means you're precise. You're consistently going at the same spot, but you're not reaching to the accuracy part. Are we getting it? And
Yes.
next one, what does the Six Sigma says? Six Sigma companies should be able to create a system where they are accurate as well as precise. As well, precise, nothing but consistency. Got it, everybody? Okay.
Yes, ma'am.
Yeah. Let's start. Accuracy.
Accuracy refers to an instrument's capacity to measure an exact value. In other terms, it is the measure's similarity to a standard or a real value. Taking small readings yield accuracy. The modest reading decreases the calculation's inaccuracy. The system's accuracy is divided into three categories as follows. Point accuracy. Point accuracy refers to the instrument's accuracy, just as a certain point on a scale. It is vital to remember that the accuracy provides no information regarding the instrument's overall accuracy.
So accuracy means you're referring to an instrument's capacity. All right. There's a measurement. Every particular company have a measurement system, correct? You will check through the system and you will be rest assured that if it's fitting in the system, that means we have received the accuracy. Simple. So taking the reading yields accuracy. For example, what is yield? We learn about RTY quickly. Roll throughput yield means, what was the meaning of roll throughput yield is? Waste in each of the units. Got it? If I have four variation, for example, if I have 4 steps, 1, 2, 3, 4 to complete one process. All right. So each of the units, each of the processes, I'll have certain percentage of waste. Yes or no?
Yes.
And that is called as RTY. Got it? All right. Okay. So likewise, accuracy means able to understand if you're having certain sets of waste, default, or defected, or errors. You will try to eliminate. So that is the modest reading says that you should able to decrease the calculation inaccuracy. Simple, right? The lesser the inaccuracy, the lesser the calculation inaccuracy, the more you reach to the accurate answer, isn't it? So system accuracy divides into 3 categories. Let us understand. The first one, point accuracy. Up to the point, like this. Simple. It's very simple. This one. It's a point accuracy where you are accurate to the core on the spot. Clear?
Yes.
Like
Yes.
this. Let's continue. So accuracy means you are exactly achieving. This is accuracy, just a certain point of scale where it's important to remember that the information regarding the instrument is overall accurate. Point accuracy means first checking whether our instrument itself is accurate or not. Please understand. Got it?
Yes.
First cross-checking the instrument itself. Clear? Next one.
Yes.
Accuracy as percentage of scale range. Kindly continue.
Accuracy as percentage of scale range. A measurement's precision is determined by the uniform scale range This can be better appreciated by using the following example. Consider a thermometer with a scale range of up to 500 degrees Celsius. The thermometer is accurate to plus minus 0.5% of the scale range, or 0.005 into 500, that is equal to plus minus 2.5 degrees Celsius. As a result, the reading will have a maximum inaccuracy of plus minus 2.5 degrees Celsius.
So accuracy as a percentage of scale range. Scale range means you have a scale, simple. You have a thermometer, thermometer have a scale, yes or no? Right?
Yes.
Thermometer have a scale. You are just understanding, you understand the scale range from 0.005, then you're going to multiply by 500 would be plus or minus 2.5 degrees Celsius. Simple. That means you're reading the highest maximum inaccuracy would be 2 plus or minus 2.5 degrees Celsius. Simple. So accuracy
Yes,
means understanding how much accuracy is required for your processes when you are reading through a certain sets of scale range. Next slide. Accuracy is percentage of true value.
The accuracy of scientific instruments can be neglected up to plus or minus 0.5% from the true value, but only up to a very high level of precision in their measurements. Such type of accuracy of the instruments is determined by identifying the measured value regarding their true value.
So the accuracy as a scientific instrument, which can be neglected. Why neglected? 0.0, that is 0.5 plus or minus, because it only has a very high level precision in the measurement system. Such type of accuracy is determined by the regarding the true value. Why 0.5 here? We're taking the same example like the previous one. Okay. So the true value means the true value would come from like this 0.5. 0.5 was a true value of the scale range. Got it? All right. So which was able to convert into plus or minus after 2.5 degrees Celsius. So true value means where it's starting point of the true value and where it is acceptable. It depends on the which of a process. So the, for example, temperature of a human body, what is the minimum should be for the understanding of a person normal temperature would be?
Anything above, so 35, 34.
35, 34 range, correct? So I will say
Yes.
plus or minus
Minus.
35 or 34. Got it now? Got it, everybody? That's my
Yes.
true value. All right. Percentage of range of scale means if I'm telling you a person is having low fever, low, what would be possibility now? Anything below 99 to 100. So what did I do? I made a scale. So if I have to check whether you people are well or not, sorry, I'm using such topic now. So I have to check. It's just a topic. It's just an example. So so what is it? It becomes my scale range. Got it? All right. Next one.
The level of agreement between the actual measurement and the absolute measurement is referred to as accuracy, the measure to which the results accord with the standard value. A single factor or measurement is required. A measurement can be accurate by chance or rare occasions. A measurement must be exact in order to be consistently accurate.
So the level of agreement means between the actual measurements, what you do actually, and the actual measurement is referred to accuracy. I'm going to take this now as a simple example. The recent example, my actual temperature went up around 105, where supposed to be having a 99. Imagine. So correct, got it. So the fever can go up and down depending. So actually, is a requirement of a percentage of a person to be normal, whereas the measurement referred to the accuracy. So that's how we check it, right? So single factor is you can able to understand, you can result the accord with the standard value, and the measurement can be accurate by chance or rare occasion, isn't it? Our body temperature change as per the humidity outside, yes or no?
Yes.
That's why it's called as chance on the rare occasion. So a measurement must be exact in order to consistently accurate. Clear? Next slide. Now, accuracy is done. Let's talk about precision. Kindly continue.
Precision. The closeness of two or more measurements to each other is known as the precision of a substance. If you weigh a given substance 5 times and get 3.2 kg each time, then your measurement is very precise but not necessarily accurate. Precision is independent of accuracy.
Correct. So precision means if you're weighing a given substance 5 times, how much time did you do it? 5 times to get the 3.2 kg each time. All right. So your output should be, we're looking out for the output variation should be around 3.2 kgs for the each time, but you are given a set of 5 times to be able to do that. Then your measurement would be very precise, but not necessarily accurate, just like this. If I tell you to have a bullseye, everybody might have tried bullseye once in a lifetime, correct? You never get exactly bullseye at one go. you have a probability. You have a probability that you might reach in different spots. That is called as precision. All right. And so you get 5 chances to reach at the exact bullseye. And all the 5 chances not necessarily needs to be very closer to the accuracy or very far. It could be intermediate. Got it? Now, under precision, you have R and R. I told you about R and R, right? Repeatability and reproducibility. Kindly continue.
Repeatability, the variance that occurs when the conditions are kept constant and multiple measurements are done over a short period of time. Reproducibility, variations occur when the same measuring technique is used by different instruments and operators across longer time periods.
What is the R&R example? R&R learnings. R&R and Gage R R. Talking about R&R now. See, the first R calls us repeatability. The second R stands for reproducibility. It's called as reproducibility, not productivity. Please not see, it's not a typo here. You call it reproducibility because you're reproducting it, and you will understand is there's any kind of differences or variations in the reproducting it, or reproducibility. All right, changes during the production itself, reproducibility. Now, repeatability means the variations occurs repeatability. The variations are constant and the variations are multiples. That is, measurements are done over a shorter period of time. When is the measurement done? Measurements are done over a shorter period of time. We're talking about over a shorter period of time, there is repeatability. It could be a chances that in any manufacturing industry, how many number of times you are repeatedly doing it could be okay, I'll just recompose myself 1 second. See, repeating any kind of mistakes, all right, any manufacturing mistakes, all right, repeating any kind of mistakes and manufacturing mistakes, and that repetition could cause a lot of loss to the company. That is repeatability. So we got to identify that mistake, we got to understand that repetition, and we got to eliminate. Got it? We got to understand, identify, and that's called as variations. Repeatable mistakes should be eliminated. Reproducibility. Now, variation occurs as the same measuring technique. The difference here is the technique itself are faulty. Got it? Here is a small error. This is the entire technique. All right. Measuring technique is a default measure, or sorry, not default, is a defect measure, which is used by different instrument operator along a longer period of time. All right. So repeatability is one operator doing the same mistake all over again. Reproducibility means multiple operators, or you have one machineries used by the multiple operator. Is there a probability to have? Is there a probability to have mistakes? Yes or no?
Yes, yes.
Human
Yes.
tendency. Human tendency.
Yes.
If I give all three of you one instrument, there's definitely a chance to get different answers from all three of you. That is called as reproducibility. All right. If I give only to Mr. Natarajan, so if I give one option to Mr. Vinod sir, so if Mr. Vinod sir is taking 3 tests using one simple sets of methodology, that is called as repeatability. If Mr. Vinod sir is doing one test, it's repeatability. If all three of you giving a different sets of testing, it is called as reproducibility. And you people turn out to become an operator. Got it now? Next slide, kindly continue.
Precision denotes the degree of variance in the values of multiple measurements of the same factor. The degree to which the results agree with one another. To comment on precision, multiple measurements or factors are required. Results can be precise but not accurate. Alternatively, the outcomes can be precise and exact.
All right. So precision denotes means degree of variation, isn't it? This is my bullseye. Simple example. What the level? Did I reach to the core level? Did I reach to the medium level? Did I reach to the outcome level? Correct? Degree of
Yes.
variance is multiple measurements at for the same factor. So degree means the result which you agree with one another. Correct? Like you will agree. Okay, it's not accuracy. We can consider another point. We can consider another point, another layer, right? So here results can be precise but not accurate because it's the result. You're all talking about experiments here. What are you talking about? Experimental basis. So we only take those results which is much more closer to the accuracy. Got it?
Yeah.
All right. And alternatively, the outcomes becomes more precise then and exact. Next slide. So that's how this accuracy value works on. Reference value is nothing but accuracy R. Please make denotion. Please note the denotion. Here R, you have accuracy R and precision means M. Clear? Repeatability and reproducibility. So here, what is this repeatability, reproducibility? This has a meaning in MSA. Okay, this is a study in MSA, a tool in MSA, sorry, it's a tool in MSA. All right, this is also called as Gage R R. Okay, this is also used in different softwares. Are we getting it now? It means the same. So the properties are same, but the features, the technique are same. Repeatability, reproducibility. All right, but it is applied in different tools and techniques. Got it? Like in MSA, for understanding the unit fault and error, in Gage R R used by the scientific team to able to understand how are we reaching to the conclusion and how much accurately we can get the precision. And finally, it is can be used to the software. Please tell me which software can you see the R right now? Is it in the Minitab or is it on the QI macros? So as I said, Gage R R is a technique, okay, where it has different, can be used, the same technique are used in MSA, Gage R R, all right, and in other stuff, which I'll be covering later on. First, repeatably means one person, we have Vinod sir here. I take an example of Vinod sir. Vinod sir is doing the test 4 times, same test, all right, same equipment. Now we have 2 people here. It could be Vinod sir and the colleagues, and that's how they both are using the similar sets of equipment. There is a possibility to have different results. Clear? Let's start. The first one, repeatability.
The variation between subsequent measurements of the same part, same characteristics by the same person using the gauge is referred to a repeatability. In other words, how much difference do measurements taken the same person on the same part using the same tool show?
Correct. So repeatability means the variation between the same part, same characteristics, same person using the same gauge. Got everybody? Same part, same characteristics, same person using the same gauge is referred to repeatability. All right. That means, in other words, how much differences do measurement taken, all right, by the same person on the same parts using the same tools. Clear? All right. Next slide. Reproducibility.
The variation in the average of measurements taken by various people using the same instrument when measuring the same characteristics on the same part is referred to as reproducibility. In other words, how much difference do we detect in measurements performed on the same part by various people using the same tool?
So the variation here, reproducibility means differences. We're able to see the differences on the average of the measurement. What are the differences on the average of the measurements? Average is here. Difference on the average of the measurements. All right. Done by various people. That means how much difference can we detect performed by the same part by various people using the same tools. Techniques are same. Parts are same, but performed by different people. Clear? Different operators. For example, productivity. If a person has been working in a daytime versus a person working in the night time, can we have a productivity differences? Yes or no?
Yes.
That's a difference. All right. Gage R R. Now, from R R is a smaller version. Got it, everybody? R R is a foundation. Now we're going to the advanced level. That is called as Gage R R. You can also pronounce as Gage R R because of the industry differences. That's it. But it means the same. I repeat again. So here, under Gage R R, you have 2 types, variable and attribute. Under variable, you have variable and continuous data. Do you remember continuous data? And
discrete and continuous data.
Correct. So variable data example would be length, width, diameter, which have certain past, present, and future. Simple. The other example is numbers, unit of measurements. Attribute Gage R R. Attribute Gage R R works for the attribution. Like go and no go. Do you remember I did in the previous slides? Go and no go. Attribute MSA. Yes. Attribute MSA. Attribute MSA and attribute Gage R R are same. But Gage R R study is used for the scientific people. MSA is the implementation in the manufacturing company. Now you got it? So attribute gauge study. When you stick the word study here, study means they are using in the R&D team, used by the R&D team. And the same study is implemented through MSA by the implementation or product team. Clear now? Attribute Gage R R, they also check through the feel, visuals, what difference it can see. Like differences in the chromosome. There's one example they've taken. There was one viral product, of the photo of a dress, which some people saw it as a blue color, some people saw it as a black color. Have you seen that? Reason because the chromosomes in our system gives us a visual differences of analyzing a particular color frame. All right. So that is the difference. Okay. Feel and visual, subjective, visual. It's a subjective thing. Okay. So under Gage R R, you have two types: variable and attribute. Simple to remember. Variable means continuous data. Attribute means discrete data. Very precise. Yes, no, pass, fail, true, false. Clear?
Okay. Okay. Yes.
Absolutely clear? Okay. Let's understand Gage R R study. Continue.
A Gage R R study can assist organizations in investigating repeatability, the amount of variability generated by the measurement equipment in the measurement system. Reproducibility, how much variation in the measurement system is caused by operator differences. Whether the variability of your measuring method is small in comparison to the variability of the process. Whether or not your measurement method can distinguish between distinct parts.
Okay. Gage R R, it's a study. It's basically a study when organizations are investing, when the organizations are into research and development team, use this in the true sense. All right. This is the reality where the scientific sets of doctors, PhD scholars, they all use this technology, this methodology. Why? They bifurcate their study into two half. Repeatability means amount of variability where equipment measurements repeated by the same person. For example, as somebody asked me, I'm taking one measurement, one system. Okay, while tool and technique, daytime, the same tool and technique, I'll take it as a night time. All right, same tool and technique. So there would be differences by the one person. The second one is variation in the measurement system caused by different operator. This doing the same task, same parts, same equipment by two different people. Definitely, there could be a possibility of human errors. All right. So what is Gage R R is again a study. It's still a study, okay, where you're understanding small comparison. You're comparing two aspects here, comparing both of them, all right, to understand the variability or the variation in the process, to understand the differences in the processes, the variation, whether or not the measurement method can distinguish the distinct part. Distinct part means this MSA help us to understand out of 5 different processes, which process has more variation. Got it? Out of 5, which one has a more variation? Next slide.
Gage R R. A Gage R R is a scientific study that falls under the larger topic measurement system analysis. When you observe any measurement, it will typically vary from time to time. The variation is the result of the variation in the object that you are measuring plus the variation of the measuring device.
All right. So the variation, see, Gage R R study itself is a part of MSA. MSA is the bigger one. All right. In the previous slide, which we did, I'll just go back to the slide just to get rid of any kind of confusion or dilemma created in your mind. This entire factor, the entire table is a part of MSA. Got it? It's a part of MSA. MSA, you are implementing. Gage R R is research. Got it? Research and R&D team use this. MSA is implementing the database over there. Got it? Now we have to understand how the differences in the object plus the differences in the measurement devices in the further slides. Let's understand this. Okay. Kindly continue. 1 second. It is here. Types of engaged. Okay, fine. There was one particular example of sunspot. Yeah, it's coming up. Fine. Okay. I'll just go back. So here they're talking about in typically what are the differences? Differences from time to time. Time to time means, for example, the sunlight time. All right. Sunlight differences. How much sunlight you can spot in the early morning at 7 a.m. Then at 8 a.m., 9, 10, 11, 12. All right. So my variation, my scale range start from 7 to 12. Correct? Is my scale range 7 to 12, 7, 8, 9, 10, 11, 12. Sunspot means if I'm standing at one spot, all right, I'll be standing at one spot, the same spot. Will I able to see the sunspot every time? Yes or no?
Yes.
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 But in a different direction?
Yes.
Yes.
Correct? That's what they're talking about. How to calculate the differences in the direction of one particular by using a same tool, but at different time. Correct? Same tool at different time. Next slide. Kindly continue.
Provides a good measure of the process precision. The Gage R and R is a simple percentage contribution of measurement variation as a function of overall variation. You want as little contribution from measurement issues versus actual process variation is possible. While you want your measurement system to provide both accuracy and precision, the gauge deals strictly with the precision component.
All right. It provides a good measure of the process precision. Process precision means Gage R is a simple percentage contribution for the MSA. What is percentage contribution? What is percentage contribution? For example, I'll give a simple example, okay? Percentage means how much percentage do you score in your academics?
Mm.
It's not really relevant to your future career. Yes or no? Simple. It might be applicable depend on your career. It might not be applicable. Even if you're failure in your school days, you can become a good CEO as a startup company. And if you've been a topper of the company, topper of your school, can be helpful to become a good, to become a good, we can say managerial post or high level manager post in a company. Probability, yes or no? Likewise, similar thing happens with everybody, even with the process. Process also depends. If a process started during the COVID times, it has a different procedure. Whereas what is right now in a different procedure. Yes or no?
Yes.
Correct? So it all about all I'm saying is Gage R is a study. MSA is the implementation of the studies. Got it? That should be clarity. All right. Now, so here we're talking about the function of overall variation. Variation, what is the variation did we see? The differences did we see? You want to has a little contribution issues that would be actual process versus possibility. All right. Possibility is way beyond. We always see sky is the limit, correct? So that we always
Yes.
differentiate between actual possibility, that is observed data, all right, and the possibility is would be any kind of referred data. All right. So you're measuring the system to provide accuracy and precision both. What does the Lean Six Sigma saying? Try to reach the accuracy with precision. Got it? Lean Six Sigma says try to achieve the accuracy but with precision. Do not have variation. All right. You cannot having variation to achieve precision, to achieve accuracy. All right. If this is my accuracy here, you cannot have variation. You can have precision. Okay. Keep on moving to the same length so that you can reach the accuracy. Got it now? Extensive computation. Kindly continue.
Extensive computations can be done using statistical software. There are a number of statistical software applications that can do the calculations for you, but you must properly design and execute the study, otherwise the results will be meaningless. To fully understand the contribution of R&R to the world economy, there are several detailed statistical computations you must do.
Like the economist use, where the Gage R studies is. Gage R is used by the WHO, by the UNICEF to understand the probability of pollution, to understand where are we, to understand about the global crisis, to understand the global warming. Have you heard about all of this? Definitely yes, correct? The climate change. What could be the repercussion? What is the today generation facing versus the next generation? All right. What is the, if it's used in medical industry as well. For example, like the any kind, like for example, life deficiencies. Our for now, right now, we have average age group is around 80, maximum is around 80 to 90. But in the next 10 to 20 years, our lower generation will having a lower life expectancy. Even that can be studied with the help of Gage R R. Got it now? All right. It can be used. How do we know the Gage R R? I've already shown with the QI macros. As I told you, QI macros and the Amini tab, which I gave it to you, is it for the implementation purpose? All right. Yeah, it's not an academic approach. No, nothing is an academic approach. In academics, it's only you have to give the exam just like you're giving your quiz. That's it. Simple MCQs. Efficiency of design. Kindly continue.
Efficiency of design. A well-designed Gage R&R study will enable you to understand the variation of your process with minimal resources and in a relatively short period of time. We already discussed employing 2 to 3 individuals, 5 to 10 things, and 2 to 3 times. This can be done in a fair length of time with proper planning.
All right. So efficiency of design means you are understanding whether the variation require minimal resources or not over the short period of time. That's what the company says, right? To have lower resources, high profit. How do they have to understand whether that low resources is a quality resource or not? To understand whether they've had a quality resources, they will use the Gage R R study. All right. For example, 2 to 3 individuals are required. They need 5 to 10 things or parts, all right, or characteristics, and doing this performing 2 to 3 times. Clear? So any Lean Six Sigma company says that to have error-free system and try to achieve the accuracy with the precision. All right? All right?
Yeah.
And make it use less number of resources and overall more output. That's why we see we people always work cross-functional. Yes or no? Everybody here. Nobody can deny the said, I only worked as per my designation. You had always worked more than a designation. Yes or no?
Yes.
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 Yes, ma'am.
That's what is the correct example of efficiency of design. Efficiency of understanding how much we can get out of one resource. Even you humans are also itself a resource. All right. Next slide. Different types of Gage R R.
Types of Gage R R. Variable Gage R R study, average and range method. Numbers, unit measure. Attribute Gage R R study. Feel, visual, subjective visual defects.
Okay, one example or data. Which type of data is used under variable Gage R R, and which type of data is used under attribute Gage R R?
Discrete data.
Very good. For where? Which one?
Discrete for attribute gauge RNA.
Very good.
Color.
And
Continuous is for variable gauge RNA.
very good. Both of you, absolutely correct. All right. Continuous is for variable and discrete is for attribute. Next slide. Kindly continue. Conducting of Gage R R.
Gauge RNR helps to determine the amount of variations present in the measurement data due to the measurement system. The measurement system is the combination of personnel, equipment or gauge, method and procedures, environment and software, etc. All collected measurement data has some variation, and GRR determines how much variations there is. Gauge RNR, the degree of variance existing in the measuring system owing to equipment and appraiser effect is defined or determined by a Gauge RNR study.
Okay, simple. Many people have done many projects in the company. Yes or no? Hello?
Yes.
Everybody
Yes.
done a project. And that project is done by your seniors? Yes or no? Hello?
Yes.
No.
The projects are done by the seniors. All right. And I'm talking about those projects which are successfully given. And you people consider this as your case study? Yes or no? Hello? Yes,
Yes,
or no?
Yes, ma'am.
And those case study becomes a threshold for you. That's a benchmark for you. Yes or no?
Yes.
And that benchmark, if you want to implement the same case study in your current process, there is a differences in the variation in the process. Why? Because that situation, era, years, environmental differences were there, correct? And the challenges which they faced are different than what challenges which we are facing. Yes or no?
Yes.
Yes.
That is what we're calling about the Gage R R study. Got it? Differences which our seniors have got versus differences which we are getting in our processes, that is called as the Gage R R study. And to able to rectify the differences, it is called as MSA. Got it? Gage R R study.
Gauge repeatability and reproducibility study. Calculate the contribution of measuring system fluctuations to overall variation. Total variance is the result of the combination of measurement system variations due to equipment and appraiser variation and manufacturing process variation. GRR study, high quality of collected data will leads to effective decision making, improve the good quality of product process, and lesser chances of error. The accuracy of a measurement system can be improved by identifying the source of variations, equipment and appraiser, and how likely they are to differ from one another.
All right. So here you have Gage R R study. It is helping us to calculate. As I said, R study helping us to calculate what? Contribution of the MSA. All right. Of the previous MSA, of your seniors MSA, what they have done. to understand how much variation did they forgot it when they were performing a process. How much variation our seniors were able to understand, and that variation, the total variation results of the combination of the current MSA, correct? The current one, a specs chart or any other reference data is because of the previous processes, yes or no? The reference data because of the previous processes?
Yes.
Correct? So,
Yes.
so we know the previous preferences, previous reference of data is due to the equipment details, is because of differences in the equipment, is because of the differences in the variation in the appraiser. Who's appraiser? What is appraiser?
The evaluator.
Evaluator, very good. Appraiser means a person who evaluates something, who takes the test. All right. Appraiser can be the operator also. You're also correct, Mr. Dinesh Kumar. In some companies, they use the term operator, whereas in some companies, they use the term appraiser. Clear? All right. So there's a difference between the appraiser, that means the human differences, and the equipment differences. Simple? So GRR help us to understand differences of the equipment variation versus human variation. All right. So it is a high quality data which is helping us to take the decision, improving the quality and reducing the chance of error. It also helps us to improve the source of variation, that is equipment and appraiser both, and how it will be differing from each other. All right. Next slide.
After instrument or gauge selections, follow the following procedures. Number 1, choose 2 or 3 appraisers or inspectors who employ the measuring system, for example, appraiser A, B, and C. Number 2, choose N, that is 10 or more, random samples from the typical production run to present the actual or expected range of process variation. Number 3, part 1 through N are numbered in such a way that the numbers are not visible to the appraiser.
See, now what they did right now, they're taking an illustration here, okay? We're taking an example illustration here, where the assumption is you're choosing 3 people here. We still have a 3 here. Mr. Charlie, Mr. Dineshkar, and Mr. Vinod, sir. All right. So you people are 3 inspectors, okay, who would be conducting the MSA. All right. I'm going to give A, B, and C the name. So you have to choose. There will be 10 or more random sample. Random sample means randomly selected. Every particular population got equal chance to get selected. So it's random population. All right. So typically production to run the represent actual number. So you have an expected range. That means they gave you a scale range. What did they give you? Scale range. Okay. So the first thing they did, they gave it a number in such a way that it is not visible to the appraiser. You people are kept in the triangle position. All right. You all 3 in the triangle position, and you're not being able to see what the numbers in such a way that it is not visible to the appraiser. Which number? The random sample numbers. All right. Next, what happens here is, after that, appraiser A is given to measure the N number of pieces. N is X. I'm taking N here as a random sample. All right. And what the A we're going to do, the operator A will compare with the observed data, his previous records, all right, to the results. Next, step number 4, the appraiser B and C will conceal the recording of the appraisal. So once he give the results, it's been done under the envelope, okay? Its result is kept under the envelope and sealed. And then they will, under the step number 4 and 5, they will repeat the twice more each time with a different random system, all right? So if 3 repeats per part appraiser, if 3 of them do the per part appraiser, what happens next is you would be able to conduct the Gage R R in real times. Okay, there are 3 people here. Yes or no?
Yes.
And I'm asking the first one. Okay, I'm asking the first operator A, to choose N number of sample. And the N would be 10 plus 1. Okay, the N would be 10 plus 1. So it will be plus or minus 1, 10. Okay, plus or minus of 10. But it is more. So I'll be just taking 10 plus 1. Okay, so 10 plus 1 is done by the operator A. Correct? So through the numbers in such a way, now operator A is, whatever operator A is doing, it is not visible to B and C. Got it? It is not visible to B and C. This is clear? This scenario is clear? What happens next? So the appraiser A is so only the since it's a test, okay, basically, so the company, the seniors will come and say they're going to allow only the appraiser A, the operator A, to measure the N pieces. What were the N pieces? How many it was? 10 plus 1. So when he was doing the 10 plus 1 and he was comparing which type of data? His previous data with the observed data. All right, with the previous records. Okay, he was able to calculate whether he was able to comply or able to take the assessment of the current records with the previous records. Okay, previous records. So here the step 4 is appraiser B and C. B and C did not witness what the A was doing. So concealing. So once he give this results, okay, now what did the A got? He got the observed data compared with the previous records. He will send this in a concealed way to the B and C. Who's B and C? Other operators. Correct? Yes. For example, Mr. Charlie got the QI macros. He understood where was MSA. So what did Mr. Charlie did? He openly showed all the share scheme, correct? What if Charlie did not show them? So what does a BNC would do? Mr.
They will struggle.
They will struggle. Yes. They will do the conceal of the reading in the other appraisers. So here they would be repeated twice more than the each time. And the random measurement will be appearing. Got it? Next one. Kindly continue.
Using the average and range approach, enter the data into the form and calculate the average and ranges of all readings for each appraiser. Calculate the condition of sources of system variation. Calculate the repeatability of for equipment variation within system variation. Calculate the reproducibility for appraiser variation between system variation. Calculate GRR. Calculate part variation. Calculate total variation. Calculate the NDC, number of distinct categories. Plot the average and range graphs and analyze the numerical results for stability.
Okay. So the point here is we're talking about is that is average. Okay. Average and the range. We know the range, right? What was the range? 10 plus 1. Correct? If you're able to calculate. So all of them got a different answers, A, B, and C. And it was carry forward. Whatever A did it, he transferred to the B, observed data. Whatever B calculated, he transferred to the C. Yes or no?
Yes.
Correct? So after that, they understand the difference in the variation in the system. They understand the differences in the appraiser because everybody got a different answer. They understand the difference in the part variation, process variation, equipment variation, category variation. Got it? But this is how if you people have seen ISO certification verification. Have you people witnessed ISO? How does the ISO inspection has been done? Okay, if you just try their strategy. ISO inspection is done. It takes around sometimes 1 month. All right. In that, the different inspector will come in and they have a different timeline to do the same task all over again. Got it? They do the same task all over again. How does a company get ISO certification? Understanding the company's whether the company is performing as per the industry standards, whether the company have the industry standard based equipments, yes or no? So there are inspectors coming up. They follow the same strategy. This is a real-time example I'm sharing with you. If any person have to get any company, any startup company needs to have ISO certification for any reason, safety, equipment, health, anything, they have to go through and they follow the Gage R R study. No one inspector give the final call. There's always multiple inspectors, cross-check their readings, cross-check their results, and then give a go. Got it? It depends on the manufacturing unit. It depends on the startup company, how lengthier it is, how small it is, how bigger the process, how smaller the company is. The timeline cannot be predicted. It depends on the variation in the process. It depends if some companies are small companies, but they're creating something different. For example, if it's small company and a big difference could be, I will not go service. I'm not going to go service industry. I'm going to talk about manufacturing industries only. So, for example, if I'm taking one manufacturing company where they're manufacturing plastic tubes, right? Simple plastic tubes, all right? And there's one manufacturing company, they are creating cars, all right? They're manufacturing cars. Imagine the entire assemble cars. So, plastic tube company and car assembly company. Simple. Which company going to spend more time on?
Car.
Exactly. Simple, right? Why? Because it has more of the variation. It has more of the processes, more of the pipelines. Correct? Simple. Got it? Now, so repeatability and reproducibility. That is simple formula. EV, tolerance, multiply by 100. AV, tolerance multiplied by 100. So repeatability. Repeatability is one operator, multiple operator?
One operator.
One
One
operator.
operator.
Very good. Reproducibility, one operator, multiple operator?
Multiple operator.
Multiple operator. I'll say 1 plus here, correct? So if it's repeating, one person is repeating, what will be repeating? Equipment, right? So it will be equipment variation. Got it? Please make a note.
Okay.
Equipment variation divided by tolerance, multiply by 100. Okay. Now, reproducibility is multiple operator, correct? So AV will stand for appraiser variation. Very good. Got it? Because it is appraiser, nothing but the operators. Clear now? AAA. AAA is again is a part of the QI macros. Kindly continue. What is AAA?
Attribute agreement analysis measures whether or not several people making a judgment or assessment of the same item have a high level of agreement among themselves. It assesses the repeatability, reproducibility, and overall accuracy of the appraisers. Every time someone makes a decision, it is critical that the decision maker select the same choice again and that others reach the same conclusion. These analysis can be used with the discrete, nominal, or ordinal data. Ordinal data groups data according to some ranking system, whereas nominal data assigns names to each data point without placing them in order. That is pass, fail, or that is scale of 1 to 10.
Thank you. So here, attribute agreement analysis, attribution. That means different, it's a part. See, what did we do in the content in the 3 sets? In the last step, we learned that all the 3 of them have different results. Yes or no?
Yes.
Operator A, B, and C, correct? So now if you have 3 operators, how do we know which operator's results is accurate? How do we find out which operator's result is accurate? We'll able to find out with the help of AAA. Got it? Please make a note. We'll able to find out with the help of AAA, attribute agreement analysis. Help us to find out which operator's result was much more accurate. All right? Which was closer to the, if not accurate, which was closer to the accuracy. Clear? If not accuracy, which was closest to the accuracy. So it's a judgment of a same item, high level among themselves, among the operators. It is helping us to assess R and R both, repeatability and reproducibility, with understanding which appraiser has more accuracy, which appraiser's readings, results, solutions, deliverables have more accuracy. Got it now? So every time someone making a decision or decision maker, we select the same choice over the other reach conclusion. Got it? Yes or no? So everybody might have reached similar conclusion. Got it? But more or less in a variation, correct? So you will able to select one best solution to able to make the as a decision maker. All right. So please, I'm going to talk about a little bit of data here. Discrete data can also be termed as discrete nominal data. Please make a note. You also have discrete ordinal data. Got it? Two ahead variation. Discrete nominal data, discrete ordinal data. Noted. Please kindly note. Discrete nominal data is one term. Discrete ordinal data is another term. I'll explain that in detail. First one, ordinal data. Discrete ordinal data. We all know about discrete data, correct? So discrete ordinal data means it's a ranking system. 1 to 10, placing in order, pass or fail, true and false, yes or no. Clear? Okay. Yes. So here the operators will give the answers in a discrete ordinal data. Got it now? The results of the operators can be a possibility of discrete ordinal data. Got it? Okay. Next slide. So here the appraiser, as I said, one appraiser says pass. Sorry, 2 appraisers says pass and 1 appraiser says fail. What is pass and fail? The process. Results. The results. Got it? So part being assessed. No. It's not a, no, you're not getting it. So these people have done their inspection. They are inspectors. Okay. So 2 inspectors says we can give the ISO certification for this company. Got it? 2 inspectors says this company is pass. 1 inspector said no. 1 inspector is offended. He said no. I'm not going to give a good to go with that. They have to get failed. So now the which one the expert will say? Expert is the Lean Six Sigma deployment leader for a smaller company. For a bigger processes or unit, it would be master black belt or black belt will search who is the best out of the three. Got it? And all the three answers would be assessed in the company premises. Clear? Okay. Next slide. The benefits of AAA. Kindly continue.
Benefits of AAA. It helps to characterize the quality of the data, identifies the area of disagreement, allows for calibrating appraisers, judges, or assessors for a higher level of agreement. Appraiser, the individual who makes the choice. Expert, the primary SME who develops the standard against which appraisers' responses are compared. Optional. Repeatability, variation in the assessment when repeated on the same portion by the same operator. Reproducibility, variation in the assessment when the same portion is assessed by the different operator.
All right, let's continue.
Benefits of attribute agreement analysis. Second, next point, it helps to characterize the quality of the data, identifies the agreement or disagreement, allow for calibration appraisers, judges, or assessors for a higher level of agreement. Appraiser, the individual who makes the choice. Expert, the primary SME who develops the standard against which appraisers' responses are compared. That's optional. Repeatability, variation in the assessment when repeat on the same portion by the same operator. Reproducibility, variation in the assessment when the same portion is assessed by a different operator.
Clear, everybody? This is very simple. It's just a revision done for you, isn't it? It helping us the quality of the data. It helping us the area of disagreement between the operators. It is helping us to align the calibrator. That is we have calibrated. That is,
Yes.
I hope you understand calibrated appraiser, right?
Yes,
Judges assessing for high level of agreement. So who's appraiser? Who is making the choice? Who's actually doing the assessment? Expert, can you see this? Appraiser, this is the other appraiser. Expert, and they are getting, and their details are being assessed. All right, the same thing is repeated in that slide. Clear? So the expert, I repeat again, expert or primary SME. The expert can be internal expert, or depending on the process, depending on the company, it can be internal expert or it can be outsourced. All right, outsource inspectors, outsource Lean Six Sigma deployment leader, outsource MBB as well, sometimes outsource black belt. But mostly master black belt, they never travel ahead because they are obligated to do that. They have to work with the same company. Black belt definitely have a lot of traveling. All right. Black belts can travel to different places, different units, subsidiary branches of the companies, and they can be internal SME and they can be the external SME as well. Got everybody?
Yes.
Yes, ma'am.
Repeatability, reproducibility, similar. One person doing all the task with the different equipment. Reproducibility, different assessor doing the same portion by the different operators, all right? Doing the task with the different operators. Let's start SPC.
Statistical process control. The application of statistical approaches to control a process or production system is referred to as statistical process control. SPC tools and processes can assist you in monitoring process behavior, identifying problems in internal systems, and resolving production challenges. Statistical process control and statistical quality control are frequently used interchangeably, SQC.
All right. SPC. SPC, we're talking about statistical process control. What is SPC? SPC is again one of the tools of Six Sigma. Okay. Why are we learning SPC? SPC are learning under model number 3 because it is helping us to analyze the data. All right. Helping us to analyze the data, helping us to monitor the data, helping us to monitor whether we are reaching out to our required spec shot or we're reaching out to the defined range or not. That is the SPC. SPC is also interchangeably used with the SQC. Statistical process, nothing but SPC is used by the R&D team, more of it. They're researcher basically. So they're going to be only talking about researching. They don't have a definite goal, all right? Whereas quality, that is statistical quality changes or challenges are used by the real time by the manufacturing industry because they are implementing these strategies. Are we getting it? These people are utilizing only for the research purpose. That's why it's SPC. People who are implementation, that is SQC. Clear? Next slide. Kindly continue.
Statistics is a science that deals with the data collecting, summarization, analysis, and information extraction. Process. It uses as a combination of people, materials, methods, machines, and measurements to turn input resources into the intended output, goods or services. Next is control. The overall output meets the criteria due to the system, policies, and procedures in place.
All right. So SPC is also a statistic. We are all, this is Six Sigma is designed, it's a collab, it's a diverse topic. I understand, please, dear delegates. It's a diverse topic. Six Sigma has a grassroots of project management. Six Sigma is one of the 7 foundation. I guess I mentioned this, right? Six Sigma is one of the 7 foundation of the project management. So here, Six Sigma has agile concept. Six Sigma has adopted Scrum concept. Six Sigma have a statistical concept. Six Sigma has Lean Six Sigma concept. And apart from that, it has software adaptation as well. So those calculation, so what is SPC? Those calculation which can be converted into a software mode can be termed also as SPC. Got it? Because you're using automation tools and techniques like collecting the data, summarization, analyzation, extraction. Simple extraction like a zip file, WinZip file. Correct? So this is also just not a science involved in the manufacturing industry. It's all talk about a lot of mathematical and statistical. There's a lot of difference between a mathematician and statistician. All right. So Six Sigma is the only subject in the world today existing where it collaborates mathematics, science, mathematics, science, economics, as well as statistics. This is the only subject. I repeat again, please make this is going to be helpful for you when you people become a master black belt. This question is also asked during the master black belt interviews. All right, the interviews question also, they're going to ask you like, is Six Sigma only statistics and people fall in trap? No, Six Sigma is a collaboration, a diverse topic with mathematics, science, economics, as well as statistician. Clear? Always remember this. I have this shortcut of when we have learned like M, that is S square ME, that is S square is science and statistics and mathematics and economics. Clear, everybody? All right. So it's a very diverse topic. It's covering up all of the aspects. All right. Because it's diverse, the only reason Six Sigma can be applied to other industry because of the diversity. And that's the reason. And because this diversity, it is applied just not in manufacturing industry, though it was the first inception of it, the pioneer, it is already applied in the as a service industries as well. Clear? Statistics is a science that deals with the collecting of data, summarization, analysis, and information extraction. And then when the statistics is approached, statistics with the combination of process, you're having a process in the statistics. That is how they combine people, material, men's. Please, do you know 5 M's? What are the 5 M's?
Material, method, machine.
Mother Nature.
Very good. Mother Nature and man. And man. Okay, this terms that man. We have 5 M's in the lower bells. The similar approach. Next, finally, we have control. The control means overall output should meet the criteria due to the systems, policies, procedures in place. So here, every particular, see, you having a statistics, you have a history of Six Sigma, correct? But not all the tools and technique will apply to Mr. Charlie's company, to Mr. Dinesh Kumar's company, to Mr. Vinod sir. Everybody have the different statistical tools, correct? Right? Yes. Then the same tools have different processes. Yes or no? Everybody might be using the similar tool, but they have different processes, correct? After having a similar different processes, the reason of different processes, because they are following different country level procedures. It's just not one company procedure. Company procedures is affected through the terms and conditions, the policies, the privacy laws, because the data we're talking about privacy laws, it is all depends on the overall country policy procedure. Clear? All right. That's how the bifurcation comes. Moving further. What are the benefits of SPC? Kindly continue.
Benefits of statistical process control. Reduce waste and rework, boost productivity, enhance overall quality, match the capabilities of the process to the product demand, maintain control by continuously monitoring the process, provide data to aid decision-making, make the procedure more efficient, increase product dependability, possibility of company-wide improvements.
Okay, simple example I'll take. Like for example, Mr. Dinesh Kumar, he is into pharmaceuticals, and they manufacture. What do you manufacture? What medicines? Is it a liquid form or a tablet form? What exactly do you manufacture, Mr. Dinesh Kumar?
It is a tablet form.
Tablet form, okay. So SPC directly if you're using that tool SPC in your manufacturing units, you'll be able to understand, is there any abnormalities? Is there any error? And most important, find out whether the weight of that one tablet is equal to the defined range or not. Got it? It goes to the weight factor, whether the weight of that particular, a tablet content is equivalent, is equal to the other units only also or not. All right, as per the defined range. Got it now? So SPC here help us to find out two important factors: abnormalities and the grams and the overall content of that particular unit. Clear? So that's why the benefits, it reduces the waste. It's helping us to reduce the rework. Lean Six Sigma company always do not believe on reworking. You can get new mistakes every now and then, but you cannot be repeating the same mistakes. It's helping us to boost the productivity, overall quality, product demand, continuous monitoring, helping the decision making. Procedure becomes more efficient, and it will always help you to make sure that the product dependability always occurs. Product dependability means that is you are continuing with a similar persistent, that means you're persistent creating good sets of product and possibility of company-wide improvements. All right. Next slide. Here we go. How do you perform the SPC? Kindly continue.
Performance of SPC. Number one, identify the process. Determine the essential process that has an impact on the product's output or the process that is extremely important to the client. In a manufacturing company, for example, plate thickness affect the product performance. Then analyze the plate manufacturing process. Number two, determine measurable attributes of the process. Determine the attributes that must be measured throughout the production. Consider the plate thickness as an quantifiable feature in the above example.
So SPC, one important factor before performing. All right. The one important factor is we got to understand that SPC is helping us to monitor and control the product quality. Always remember, simple language. Monitor and control the product quality. That is the main term for it. Okay, main interpretation. Monitor and control the product quality. Now, to able to understand understand the variations, all right, in the particular assembly line, you have to understand under the SPC you have two types of variation. What are two types of variation? One is common cause variation. What is the other one? Mr. Dinesh Kumar Vinod sir?
Special cause.
Very good. Common cause variation and special cause variation. Common cause variation and special cause variation in detail. But these two variations should be there in mind. That's how the SPC is supposed to be performed. All right. So here, the first one, got to identify the process. Identify means understand what, as we define the process in any DMAC or DMA-DV, in the SPC, you're going to identify the process. And what are the exact impact of inputs to the total product's output for the process. This and that particular output should be able to address as per the client perspective. All right. Example, they've taken a plate thickness, affect the performance, then analyze the plate manufacturing process. So if the thickness of the plates ultimately depends the manufacturing processes. So the second step is measuring the attributes. What is the measuring the attributes? Is understanding what should be the thickness of the plate. And here, let's take another example here. The similar example, kindly continue.
Determine the measurement method and also perform Gage R R. Creating a measurement system that is reproducible and repeatable. Gage R R define the amount of variation in the measurement data due to the measurement system. For example, consider thickness gauge to measure the thickness and create an appropriate measure procedure. Create a measurement method, work instructions, or procedure including the measuring instrument.
Correct. So here under the third step, you are applying our very well known the Gage R R. All right. This Gage R R, we've already done. What are the R R? Quick revision. What is R R?
Repeatability and reproducibility.
Very good. Repeatability, how many operators?
One operator.
Operator.
Very good. And reproducibility, how many operators?
Multiple operators.
Absolutely correct. So under the SPC performance itself, you are using the Gage R R as a third step. All right. So under that, you're able to understand. So like we have done the three, there were three operators example, correct? We've taken the three operator example. You would be conducting the similar way of the Gage R R process under the SPC. Clear? For what? To able to understand whether the measurement system should be, to able to understand whether the thickness of the plate is approximately, is it going to be workable for the company and how long they can predict the data. This measurement method, work instruction or procedure. It also involved measuring instrument. All right. So operators will also be using instrument, correct? That's what we learned, right? The repeatability and reproducibility would be a part of the, so it, see, Gage R R itself is a statistical process, a methodology. But Gage R R can be also done, and it has been done, followed under the third step of SPC. Yeah, next slide, the fourth one, kindly continue.
Yeah, develop a subgroup strategy and sampling plan. Determine the subgroup size based on the criticality of the product as well as the sampling size and frequency. For example, in a time sequence with a subgroup size of 4, collect 20 sets of plate thicknesses. Next one is collect the data and plot SPC chart. Select an SPC chart based on data type, continuous or discrete, and also subgroup size. For example, plate thicknesses with a subgroup size of 4, select X bar R chart. Collect the data as per sample size and choose appropriate SPC chart for the data type you are looking at.
So now, what are the second step we're doing? As I said, SP is all about analyzing the database, correct? So we will be now proceeding with the subgrouping the strategy, all right? Like with the sampling pen, how the subgroup is, that is for the time sequence, size of 4, collected with the set of plate of thickness, what time base, all right? Which month base, for example, you're grouping a system. So for example, it could be different versions, all right? Or different designs probability, correct? Can be brought out into one particular unit, and that unit can be done as a subgrouping unit, correct? Based on that, you can be collecting the data, and then you're going to plot the SPC chart. Two types of data we always learned about, correct? Continuous and discrete, correct? So SPC can be done on both the parts. SPC is one of those chart, one of the important point to be noted. SPC is one of those chart which can be done with the help of continuous data as well as discrete data, both of them. All right. So the place thickness is subgroup size of 4. So what you're going to do is select the X bar R chart. Where you get this X bar R chart under the QI macros. Got it? So you don't have to do any of this 4 steps. Just fill in the database, go to the QI macros and select the X bar R chart, and your data would be interpreted as SPC. Got it, everybody? Kindly continue.
Number 6, describe natural variation of attributes. Determine the control limit. Calculate the upper control limit, UCL, and lower control limit, LCL, for both X bar range using the example above. Number 7, monitor process variation. Check the control chart to see whether any point are out of control and the pattern. Consider the X bar R chart. If the process is out of control, discover the root causes and address the problem. This is continuous process for monitoring process variance.
Okay, I will give you one sample calculations today with the steps before the end of the session. Kindly try doing and following the steps, okay? In that, the first 3 steps is eliminated because you already have X bar R chart. I'll give you a calculation and you can decide your own UCL and LCL. Got it? You just like feeding your data, you're feeding your data, and you will see the X bar R chart has been created. Clear? Okay. Next slide. This is how this X bar R chart looks like. All you got to do is feed in the data of the UCL and the LCL. All right. And then you can also give this is the observed data, the average X bar, the observed data. You got to give them feed in the data in the Excel format, the simple formats, and the entire X bar R chart would be created. Likewise, range chart as well. Range means you have a defined range for that. See, only the difference between X bar R chart and range chart is they do not have an average for it. Got it? They can fall below the LCL. They can fall above the UCL as well. Got it? Okay. They can break through the defined range. Simple as such. Range chart is they can break through the defined range and do not have an average. Range chart does not have an average. Problem solving techniques. Finally, we are coming up to the 7 QC tools under the 6 Sigma. Kindly continue.
7 QC tools. In today's customer-centric market, quality is an integral factor in the growth and sustainability of any business. So businesses who wants to ensure competitive and excellent quality of their products and services can utilize the proven 7 QC tools for structuring a strategic plan for quality. Introduced by Karon Ishikawa, the 7 basic tools of quality are very effective in quality management and assurance process.
So 7 QC tools, all the 6 Sigma. Now, why it is 7? Please try and understand. it is more than 7, but why only 7 we highlighted? Because 7 are the foundation of Six Sigma, I will say. Okay. So for example, if I have, what is the 7 foundation? Can you give me an example? What of those 7 foundation? What is mentioned here?
Pareto chart, and then control chart,
Come on.
Histogram,
histogram, Ishikawa fishbone diagram,
fishbone,
Fishbone
scatter plot.
diagram, control chart. Very good.
scatter diagram.
Correct. Okay. Now, why these 7? Based on this 7, you can do further advanced tools. Are we getting it? These
Yes.
7s are the foundation of Six Sigma. Based on the 7, okay, if you pick up any one of them, all right, under the control chart, you can create any other chart as well. Like based on the control chart, you can create the S chart, R chart, X bar chart. Got it? All right. So based on the Ishikawa diagram, 5Y. All right. The fishbone
5Y.
diagram. Correct. So the fishbone
Yes.
diagram will help you to calculate the SPC. It will also help you to calculate the other statistical questionnaire problem as. Are we getting it? So this
Yes.
5 becomes the major top. Like it's like a pillars. Based on that, each of them, you can able to create, perform other calculations. Got it? That's why
Yes.
they have marked as 7 foundation. Clear? It has more than, currently Six Sigma has more than 30 different 30 different types of tools and techniques and calculation. But it is now, we can break down into 7 pillars and then we can put it into 1 by 1 bifurcation. Got it now? Like a subject. All right. And these tools becomes the subtopics of the subject, the 7 subjects. Clear? Moving further, kindly continue.
7 QC tools are: number 1, check sheet; number 2, fishbone diagram or cause and effect diagram or Ishikawa diagram; third, histogram; 4, Pareto chart; 5th, control chart; 6th, scatter diagram; 7, stratification.
Let's proceed further. So this is how the check sheet looks like. Simple tally, simple computation we've been doing it, that we've been doing from the school days. All right. Check sheet is you are drawing the check sheet with the help of Excel sheet also can be done. And you can do this offline as well. Clear? Checklist is you get a checklist that Mr. Charlie is supposed to start the work by this time, end the work by this time. And 2 days, you got to reach a KRA. You have to able to get down your KPIs by given by your other teams and the members. Got it? Checklist is the daily task. You got a checklist. Or any particular manufacturing product, if you have a product, the checklist would be you need to have all the checklists before proceeding to another step, another process. Got it? That is checklist.
Predefined data.
Predefined, yes, exactly. Predefined.
And the check sheet?
Check sheet is a observed data.
Okay, observed data, yes. Yes, we collect data.
Exactly. And then you're using as a computation. Clear? Next one. Fishbone diagram. Kindly continue.
Fishbone diagram. Fishbone diagrams are a type of problem analysis that involves drilling down to find the root cause of a problem. The diagram looks like the bone of a fish, where each main bone represents a specific category of possible root cause, and the subsequent drilling down is shown as smaller and smaller bones.
All right, fishbone diagram is also called as Ishikawa diagram. All right, that is because of the creator name. It looks like a fish. It has 5 questionnaire to be raised. Okay, this is the center mediator, and they make the particular set of seating arrangement according to this methodology. All right, this methodology help us to understand the root cause of the problem. This 5Y is derived by the 5 or 6M. It is first, earlier it was environment, now it is mother nature. Okay. Earlier it was environment, now we refer as mother nature. So the 6M. The fishbone diagram, all right, also terms as the 6M or 5 Ys. Clear? Next slide.
Yeah, histogram is a bar graph showing the frequency of set data, usually continuous data. The histogram allows you to see the center of the data, the range of the data, and the distribution of the data. It is very useful snapshot, but on a computer screen, you can't see the sequence or order of the historical data.
Correct. Please make a note. Histogram is designed for which type of data? For continuous sets of data. All right. Histogram is designed for the continuous sets of data to able to understand. So we'll be doing about how to do the histogram. We'll be understanding what is histogram, the terms, how does it evolve into today's generation, how it is affecting and how it is interpreting and helping the companies to able to do real-time calculations. Clear? Everything. So all the 7 QC tools will be explained each and every time in the further slides. All right. But it is data related. It is like a bar, and it is only deserving. That means you can only wait to any deserving candidate, any deserving black belt should know how to able to proceed about the histogram. This is how the histogram looks like. Okay. Simple bar chart. Okay. And it will only show the observed data with the help of frequencies. Next slide. Pareto chart.
The Pareto chart is based on the 80/20 principle, which says 80% of your effect is caused by 20% of causes. It lists the causes in descending order of frequency or magnitude. It is used to prioritize what you should look at first to improve your process. Dr. Joseph Juran often referred to this chart as the vital few and trivial many.
It's a very huge story behind Joseph Sudan, sir. As I said, histogram, Six Sigma is a concept where people have evolved from centuries. The first was the Greek to use this. Slowly, gradually, it moved from the America, then moved on to Japanese. All right. So it has a presence way back in 15th century. All right. As old as 15th century is too much old. Correct. So the one particular Pareto chart, again, one of the oldest form, this was derived in the 16th century. Imagine 16th century. Then, so it was so what happens is the same concept was got a lot of refinement. Okay. Then it was popularized by Joseph Juran as a 80/20 rule. This chart is also called as 80/20 chart or 80/20 principle. This got popularized by Joseph Juran. Joseph Juran says that vital few and trivial many. Vital few means you have to understand that 20% of the employees are working for the 80% of the profit making in the company. Got it? That's as called as trivial many, but that is many people have put in the hard work for that 80% of the production. Input is given by the 20% of the employees. Got it, everybody? Next slide. This is how the Pareto chart looks like. All right. You will able to see this is a little bit different from the histogram. You'll able to see under the Pareto chart, you'll also able to justify and analyze the returns and the refunds. Why? See, Pareto chart is applied for the service industry, for the logic. Even Amazon, they themselves use Pareto chart. For what they use Pareto chart? So Pareto charts also is a part of the service industry where they also calculate real time the refunds and returns. Please go to Amazon Logic Centers and we will see Pareto charts kind of a diagram stuck on the manager's desk or the billboard or the blackboard they have. Got it? So they have this monthly figure about returns and refunds real time used by the logistics centers. Clear, everybody? Next one, control chart. Kindly continue.
Yeah, control chart is a statistical technique that examines your process data over time to differentiate between special cause and common cause variance.
Correct. So here, special cause and common cause. Okay, so can you see, we just talked about SPC, correct? I said under SPC you have two variation. Okay, please make a note. Under SPC, we use the term special cause variation and common cause variation. Please make a note. And okay, so if you're using under SPC, you will use the word variation. But when you're using under control chart, you'll use the word cause. Got it? But both the similarity, but both have the same. It means the same. Okay, I'm going to give you a quick example. What is special cause? What is common cause? It is coming ahead, but for now, just to understand, special cause. Special cause means, for example, COVID. Got it? COVID made the online education system much more comprehensive, isn't it? We have a school called 24K school where children don't even go to the school. They have everything done at home. So it's a fully online concept, correct? Which was adopted post-COVID, correct? Now, common cause. Common cause would be equipment breakdown, employee burnout, all right? Common cause are those which can be identified. All right, which is something common. Special cause are those like COVID situation, earthquake. Recently, Japan, last year also Japan have seen the earthquakes, correct? Tsunamis. All right, are we getting it? Okay, any natural calamities, or it could be any kind of biggest, the con master we have, we say con master, fraud, big level, corruption, big level. which is making the entire company goes shut down. These are the special causes. Got it, everybody? Simple language. Got it? Okay.
Yes, ma'am.
Yes.
So under the control chart, you will use the cost term. You'll use the word cost. But under SPC, what you will use, everybody? The similar concept you'll use as a,
Special cause.
Special.
but what was the difference? One term.
Variance.
Very
Variance.
good. Very good, Mr. Vinod sir. It is called as variation. Special cost variation and commerce cost variation. Clear? Okay.
Yeah.
Next slide. Scatter diagram.
Scatter diagram. These are also referred to as scattered plots. They are used to display a graphical correlation between a pair of data points on an x and y axis. It is a graphical representation of what would be used in regression analysis.
So here, scatter plots are also helping us to understand the dots. Please make a note. Scatter diagram, scatter plots or dot plots. These are the two ones, very, very adaptable to the globally. It looks very simple diagram, right? But this diagram helping us to even search and learn about astronomy. All right, about astronomy, about stars, about prediction, about temperature. This is scatter plots. Scatter plots and dot plots are famous by the scientists. Scientists love those dot plots and scatter plots. Clear? Okay. Next slide. Stratification.
Stratification. This is a graph that it displays data that has been stratified when it originates from various sources. Viewing the data by strata such as shift, gender, geographic region, machines or suppliers is beneficial.
Okay. Stratification. You are grouping. What are we doing? We are grouping our data. Grouping with the help of gender, geographic regions, grouping with the help of interest, grouping with the help of the population. That is, when I say population, the population of the men's and the female, gender biases. All right. That's called stratification. Likewise, you'll be stratifying machinery 1, 2, and 3. And then based on that, the spot. Can you see the spots? The spots is observed data. Got it? The spots are the observed data, real time. You'll be able to identify which machinery is giving maximum number of output. Got it? That's called stratification. Next, these are the 7 QC tools. I repeat again, based on the 7 QC tools, you can create multiples of them. This is the foundation and you can create multiple out of them. That's why this becomes the most top 7 QC tools at the Six Sigma. Clear? So I like to give you one hack. Please make a note. If you people really want to become a master black belt and the black belt in your company, please focus only the 7 QC tools. If you're focusing in the 7 QC tools and how to implement that, you already learned, you are much more ahead than your competitors. Clear, everybody? Whichever company is able to work the best, or for example, if it's a research company, what will come first? Example, let's take a research company and manufacturing company. Okay, two companies example, simple. If it's research company, which one will come first? Exactly. And if it's manufacturing company, what should come first? They can use cause and effect diagram. They can use Pareto chart as well. They can use histogram as well, correct? Before the Six Sigma, before the adaptation of Six Sigma, people still have quality control tool. People still have QC team. People still had the processes of monitoring. Yes or no? Correct. So how did they do that time? I'm talking about the 1800 and 1900 century. What did they do? What is Six Sigma? The company already have a quality control team. They adapted the Six Sigma, whichever is suitable in their company. And that's how they created a Lean Six Sigma for your company. What is Lean Six Sigma? Whatever QC tool you already have in your company, addition to any of these ones, that's what makes the company Lean Six Sigma. Got it? So you're not changing the entire company processes. It's going to be costing bomb for them. Correct? You're not changing. You're just alterating. You're just doing the alteration thing in your company. Clear now? Okay.
Yes.
Otherwise it's going to be very costly effect. All right. Next slide. Kindly continue. This is going to be very general thing, quality control techniques. We're talking about those times which is basic thing of happening. Let's start inspection.
Inspection. Inspection is that component of quality control which is concerned with checking on the performance of items to the specifications set for it. It involves periodic checking and measuring before, during, and after the production process. Because of the numerous variables that enter into manufacturing, inspection is a never-ending process. inspection or maybe centralized or floor inspection?
All right, inspection. As I said earlier also was inspection. Before Six Sigma, also there were people, there were tools and techniques. Our ancient times, we have a history, proven history that our Asian, history has been more the architecture. We cannot design today. Can we design today? Is it practicality? No, it's not practicality, because there had been war, there had been the conspiracies, correct? Right? Inspection. So whatever tools and techniques currently a company is running from the, like for example, any traditional technique collaborate with the Six Sigma will make your company Lean Six Sigma. So you cannot have a format. Every company is a customized. You cannot have a format. All right. So the first thing, inspection. It's a periodic check. And inspection means you're checking before and after and during the production. There are numerous variables. All right. Variation. What are those? That is the variables that goes inside the manufacturing process and which requires rigorous sets of inspection. And inspection is a never-ending process. Ask auditors, all right? It's a never-ending. It's always going to be a certain sets of, it's a vivacious cycle. Inspection can be centralized or floor inspection. Centralized means you are following one rule and given all the subgroups. That is the different branches of a company or one branch, every branch have their own sets of rules to follow for the inspection. Clear? Next slide. SQC. What we can do about this thing? We can go one by one person taking one page. Okay. So we can go like one by one. All right. Yeah. Can we continue?
Statistical quality control. SQC is founded on probability law. It is a technique for managing the quality of manufacturing within specified limitation, that is tolerance limit, using a sampling procedure and ongoing inspection results analysis. SQC is a simple statistical tool for measuring the extent to which quality goods are satisfied without necessarily inspecting every time produced and noting whether or not the variances that occur surpasses typical expectations. It allows us to choose whether to reject or accept specific.
SQC, as I said, SPC and SQC are same, but the terminology, they are interchangeable. All right. So what does the company use? Company first use inspection. The second technique company use is SQC. All right. SQC help us to understand the tolerance limit, specified UCL and LCLs. That means SPC says if we have to work within our defined range. All right. It's a simple statistical tool helping us to understand and monitor the product and understand what are the variations. Variations should not surpass the typical expectation. So if we expected our data should be above 1 to 10, it should not surpass above 10. If it's above 10, then there is an error in our data. Clear? So it should meet our typical expectation. And that's how it is helping us to either we're supposed to reject or accept the specific product. Now, hypothesis testing, it's something going to be a little bit. So hypothesis testing is one of the best testing tools which is currently performed by the companies. Currently acceptable tools and techniques we have. Under this hypothesis testing, you have two types. That is alternative and what's another one? Null and alternative. Please make a note. You have two types of testing, null and alternative. Let's learn about this in detail. Let's start.
Hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding a population parameter. The methodology employed by the analyst depends on the nature of the data used and the reason for the analysis. Such data may come from a larger population or from a data generating process.
Okay. Hypothesis testing is you're able to understand, you're putting up an assumption about a population parameter. What is population parameter? That means it is helping us to understand the relationship between two statistical variables. All right. Okay. So here, example could be a school teacher. Okay. A school teacher assumes that, all right, a school teacher can assume that if based on the results, how many percentage of the students require more practice in maths? How many percentage of students are very well to do with the maths? Clear? Simple example. Based on the results of the report card, we can make a bifurcation about the population. How many of the students require more practice in maths? How many percent require more or are better in different subjects compared to the maths? So it is a statistical process which helps us to understand two statistical. For any hypothesis testing, you require two variables. Got it? That means two samples. Clear? Next slide. Kindly continue.
Using sample data, hypothesis testing is performed to examine the plausibility of a theory. Given the facts, the tests give evidence for the hypothesis plausibility. Statistical analysis put a theory to the rest by measuring and analyzing a random sample of the population under consideration.
Okay. So here, how do we know? Have we seen men's are always taller than the female? Simple example. Yes or no?
Yes.
Globally, is this globally? Yes or no?
Yes.
Correct. Now, hypothesis testing will help us to understand the relationship between the, for example, when you test a relationship between the gender and the height. Okay. Test relationship between gender and the height. So what will take the entire India population, the average men would be, what would the average men's height?
5.6.
Okay. And the maximum can go on to highest, correct? What would the average woman's height could be?
5.2.
And 4.
It starts with 4. Some of them are 4 as well. I've seen 4 or 5. At the latest 5, correct? So hypothesis testing will help us to identify men and women height range, the lowest to the height range to the maximum. Got it? So what are we doing? Under hypothesis testing, you're comparing the height of the two gender. All right. You already have the data. We always have the data. The data should be accurate. If the data is not accuracy, the entire calculation, any type of calculation will go into vain. All right. So here, simple testing can be done about the gender and the height. And that's how we come to know basically that men's height will always going to be having more than the female's height. That is a basic understanding. All right. So based on the body of knowledge, physiology, you can formulate a hypothesis testing that the men are on the average always taller than the female. Clear? Now, given the facts, you need evidence for the hypothesis plausibility. That means your data should be having a factual test, and this theory would be tested by the measuring, analyzing a random sample population under consideration. Random sample population, that means a random thing. All right? You're selecting any random sets of people. There's no quota sampling. We learned about sampling, correct? 4 steps of hypothesis. Kindly continue.
4 steps of hypothesis testing. All hypotheses are tested using a 4-step process. Number 1, the analyst must first state the 2 hypotheses so that only one may be correct. Number 2, the following steps is to create an analysis plan that explains how the data will be assessed. Number 3, the third stage is to put the strategy into action and physically analyze the sample data. Number 4, the fourth and the last stage is to assess the result and either reject the null hypothesis or conclude that given the evidence, the null hypothesis is plausible.
Okay. I'm going to talk about very important here that is called as the 2 types. Okay. Before explaining this, null and alternative. If you want, please make a note. Null versus alternative hypothesis. Okay. Okay. Where do I type in? I'll type it here itself. Okay. Null and alternative. All right. Okay. Null. The denotation of null is H O. All right. H0 and alternative is H1. Okay. All right. H0, H1. That's the denotation. Clear? So please make an alternative type. Alternative also have H1. Sometimes it is also called as, in some countries, they also accept it as HA. All right. Null is H0, alternative is H1 or HA. So under null hypothesis, what happens? Please make a note. Every test of hypothesis, they have to 2 test. All right. Every test of hypothesis, they have to 2 test. All right. Every test. If you said I'm doing hypothesis testing, you're doing 2 tests. What are 2 tests you're doing? You're doing like this. You're doing 1 test that is called as, I'll type it here. This is a favorite slide. Null hypothesis is also denotes as, you can denote this as H. Okay. H0. All right. Alternative hypothesis. Where else? Alternative hypothesis. Here, please make a note. This will be, this not part of the curriculum. This is termed as H1. In some industries as well as in countries, they're using HA. This is clear? Okay.
Yes.
All right. And then null hypothesis. Every hypothesis testing, you have to do these two tests. Under one test, you have to perform both the tests. Clear? So under null hypothesis, okay, null means always trying to justify whether your particular test has uniformity, is equal to each other. All right. Your comparison will always come as equal. Null means there's nothing, there's no difference. All right. Alternative means they've seen variation. Alternative means you have seen variation. All right. That means the two of them will be not equal to sign. Okay. I'm unable to give them. I'll just put it here. It will be not equal to each other. Is this clear now? Simple?
Yes, ma'am.
Yeah. Null hypothesis is also called as alpha risk. Alpha risk. Alpha is also called as company risk. Please make a note. Alpha risk. And alternative hypothesis is also called as beta risk. Beta risk. One is company, one is customer. Clear? When you're performing, it is called as hypothesis testing. And when it has been proven from the company as a result, it is called as a risk. Correct? So the terminologies are changing, but one is an academic terminology. The other one is implementation terminology. Clear? Okay, let's start about both. All right. So please remember, alpha risk is the null and beta reward is the which one? Which one? Which type of hypothesis?
Alternate hypothesis.
Very good. Alternative hypothesis and the customer risk. Correct. Kindly continue. Next person. The first one, alpha risk.
Alpha risk. The danger that a null hypothesis will be rejected in a statistical test when it is actually true is known as alpha risk. This is referred to as a type 1 error or false positive. The phrase risk refers to the possibility or likelihood of making a bad judgment. The sample size employed for the test is the key driver of the degree of alpha risk. In a particular, the larger the sample size tested, the smaller the alpha risk. Alpha risk is distinct from beta risk or the risk of making type 2 error. We test a false negative.
Okay. So for example, what is alpha risk? Okay. Alpha risk is, it's also, please make a note, alpha risk is also called as, one more distinguish between here, important point I missed out here. Alpha risk is also called as type 1 error. Okay. Type 1 error in the company. And beta is called as type 2 error. Got it?
Yes.
Please make a note. Type 1 error and type 2 error. Okay. Please make a note. All right. So moving further, what is alpha risk? False positive and false negative. What do you mean by false positive and false negative? Okay. Please make a note. Alpha risk is different from the beta risk. Alpha risk is type 1 and alpha risk will be false and positive. That means the risk would be of making a bad judgment. Bad judgment, for example, the sample size employed for the test is a key driver for degree of alpha risk. Sample size. You cannot judge the entire population with the sample size. Is it possible? Can we do that? Can I assume if you people are coming up with this particular course and you have experience with a black belt, but just with your interpretation, can I assume the entire company and their employees knowledge of a Six Sigma? Is this practical approach? Yes or no?
No.
No, correct? So that is called as false positive. You cannot be judging or it. And the larger sample tested would be the smaller the alpha risk. So always in the alpha risk, it's type 1 error. I'll give you the real-time example. Do not worry. When you're comparing with the beta risk, alpha risk is also called as company risk. Company take the risk to able to perform the test. Clear? So it can come as false positive or false negative. False positive means you are true to the statement and you still, it's a negative. Okay. So for example, I'll give you a very wonderful case about, you might have heard about Arushi case. Yes or no?
Yes, ma'am.
Right? I'll
Yes,
give you medical also, but now it's very still in my mind. So here, it is like, because of the judgment was wrong, the parents were termed as victim. Yes or no?
Yes.
Correct? Do you agree with that? It's very complexity. We still do not know till today's world whether it was true or false, correct? But
Yes.
it was positive, but it was falsely judged. Yes or no?
Yes.
Yes.
Correct. It was positive, but it was false. But if the judgment was done correct, then it could be negative as well. Correct. Right. The false judgment. What if the judgment was correct? Correct. So it is called as false positive. That means they were actually the culprit and it was positive. False negative means they were victim and but they still went behind the bars. False negative means they themselves were simple judgment. If it's a wrong judgment, please make a note. The similar hypothesis testing is also done real time in the criminal cases as well. All right. I've done my paralegal by UK. I know that I have learned about the cases. Hypothesis testing just not for the product or for the assumption for the database. It can be also done understanding the cases earlier. That's why the cases also get reopened. Sometimes the cases got reopened. All right, because of such kind of testing. Next one, for the medical industry. For example, type 1 error could appear the appearance in the treatment. All right, appearance in treatment. For example, there is a disease. Okay. Either there are two people here, right? From you and Mr. Dinesh Kumar, correct, Mr. Vinod sir? Yeah.
Yes, ma'am. Yes.
Correct. So in medical testing, how does the hypothesis works? Okay, medical testing for type 1 error. Type 1 error is also called as
Alpha risk.
alpha risk. Alpha is also called as
Company risk.
Company risk.
correct. What is absolutely correct? But it is also called as which type of test?
Null
Null.
test. Null test.
Null test. Very good. The null test. Correct. Okay. So thinking in that in mind, what in the null test, what are you trying to still find out? Whether both the proportion are null. It doesn't have any differences. Correct.
Yes.
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 Okay. Keeping this concept in mind, just listen about this. Okay. Listen about this real-time examples. For example, in medical testing, a type 1 error would cause the appearance that a treatment for a disease and that can affect the reducing of severity of the disease. What are you trying to understand? Not completely vanishing the disease, but reducing the severity. For example, cancer. Cancer, correct? What you can do, you can mitigate the severity. In fact, when a new medicine has been tested, the null hypothesis will be that medicine that does not affect the progression of the disease. Got it? Hello?
Yes.
For example, if I am, okay, if God forbid there should be no cancer patient, but for the cancer patient, if we four of us, if you're practicing, if you're creating any kind of drug, so we see that the drug is not making the cancer patient progress for that particular disease. All right, not even diminishing, but it is in a stable position. That is called as null hypothesis. Got everybody? All right. Okay.
Yes.
This is how it is used criticality. It is used by the researchers, scientists, developers. I would say what not. Even the AI technology, leave everything else. Hypothesis testing also can help us to find the AI. So what was AI technology with this? For example, self-driving Tesla cars. Okay. So they changed the plan between them, but they were not able to change the plan amongst them. That means the interpretation. So your phone, the iPhone is synced with the Tesla car. So whatever you are interpreting on the phone where they're supposed to land up, the Tesla car will going to take you like a self-driving Tesla car. All right. You can imagine the kind of students coming up to the sessions to learn Six Sigma. So that's how the challenges are. Are we getting it? Even for the AI technology. So it's real-time challenges. You cannot even predict. Got everybody?
Yes.
Got it?
Yes.
The cancer drug test understood? Okay. That's how the alpha risk is considered as a company risk. It's a risk from the company. And see, why it's risk from the company? Because the companies, for example, a pharmaceutical company, it will be a risk for the cancer patient. It can have a repercussion as well. It can have a negative impact as well. Isn't it, Mr. Vinod sir? Right?
Yes.
It can
Yes.
have a negative impact as well. So it is a risk from the company side, and the company is ready to take the risk and work on it. Clear? All right. Now let's continue for alpha risk.
Alpha risk, also known as type 1 error, happens during hypothesis testing when a null hypothesis is rejected despite the fact that it is correct and should not be rejected. The null hypothesis assumes that there is no cause and effect relationship between the tested item and the test stimuli. A type 1 error is effectively a false positive, resulting in the null hypothesis being rejected incorrectly. In statistical decision making, alpha or active return from investing is unrelated to alpha risk.
So till now, can somebody interpret what was the example of the cancer patient? What did we learn about the cancer patient?
Yes, ma'am. So if there is no, effect of the drug, right? Efficacy, if we say the efficacy of the drug, then still, then the cancer, it won't be progressing.
Hmm.
So the patient remains stable. So without
Hmm.
any progress, further progression of the disease.
Correct. So that is the type 1 error. Okay. When a
Yes.
new medicine is tested, okay, that is, we understood the null hypothesis because it does not affect the patient, but it does not increase the progression of the cancer drug. All right. Okay. So this particular null hypothesis might be that drug does not affect the growth rate of the cancer. That's what happened to the patient. All right. After applying the drug to the cancer cells stop growing. Got it? Where it is affecting? At the cancer cells. So the cancer cells stop growing. This would cause the researcher to reject their null hypothesis. Why they're rejecting now? That the drug would have no effect. Got it now?
Yes.
Got it? But as we know, it's stopping, but it is not showing any effect to the person. That's why they are rejecting the null hypothesis. Got it? Once they're rejecting the null hypothesis, what happens next is this would cause the researcher to reject the null hypothesis, and that the drug would have no effect. Correct? What would the patient will say? What do the family members will say? He's not improving. This is not improving. Correct? We want to reject this. We want to change the medication. Correct? So if the drug caused the growth stoppage, the conclusion to the reject the null in this case, like which is just giving this example, probably would be correct. However, if something else during the test caused, all right, apart from this, something else, so there are some other parameter. See, medical industry is a very critical in one. You cannot understand, you cannot diagnose the person without fully completion diagnosis. Correct? You cannot understand the disease of the person without fully complete diagnosis. So here the similar likewise, if something else during the test caused the growth stopped instead of the administrative drugs which we're talking about, instead of the drugs which we are giving to them, then this would be an example of an incorrect rejection. That is the false negative. Got everybody? All right. False positive, false negative. Got it, everybody? Kindly continue. Next slide.
Alpha risk. The null hypothesis statistical test is a statement that there is no difference between a value and a particular number, such as 0 or 1. When the null hypothesis is rejected, the person conducting the test is saying there is a difference between the tested value and the particular number. Alpha risk is the probability that a statistical test will detect a difference when there is really nothing there. It may be explained as a risk found in incorrectly rejecting the null hypothesis when the alternative hypothesis is in fact false. If alpha risk is 0.05, there is a 5% likelihood of inaccuracy. This is a false positive.
Correct. See, there are two things. In a life, either we pass or we fail. Correct? In an examination. Correct? Do you have anything in between? Leave.
No.
Do not talk about KT. And there are students who talk about KT. Do not talk about KT. So you either pass the test or fail the test. Correct? So likewise, alpha risk means you either pass the test, zero deficiency, zero defect. All right, zero, or either you have one. Even if it's 1 point differences. Got it? Even if the test is 1 point differences or 0.05 differences, that means it is 5% of the inaccuracy. Got it? So it is either 0 or 0.1 differences. Even if there's a 0.1 differences, that there is a chance of alpha risk. That's what they're saying. Clear? Okay. Next one, beta risk. Let's start.
Beta risk. The possibility that a false null hypothesis will be accepted by a statistical test is referred to as beta risk. This is often referred to as a type 2 error or a consumer risk. The term risk in this context refers to the possibility or likelihood of making an improper decision. The same size employed for the test is the key driver of the degree of beta risk. In particular, the larger the sample size tested, the smaller the beta risk.
Okay, quick revision, everybody. Beta risk is also called as which type of risk?
Consumer risk.
Very good. Consumer risk. And it is which type of error?
Type 2 error.
It's alternate.
Type 2 and alternative. Correct. Absolutely correct. Type 2 error and alternative hypothesis testing. Correct. Okay. Now, see, The only thing the beta risk has to do is they have to make sure that if it is false, all right, if it's positive, that means null is winning. Okay. If it's negative, that means it is alternative. The answer directly goes to the alternative. Simple. Agar positive hai to equal hai na. If it's positive, then it's equal. If it's not positive, if it's false, if it's negative, that means it is an alternative sign. So for drug testing, if it's working, the progression is working or stopping. Sometimes we can see the cancer patient is at the moment, he's not even curable, he's not even declining, he's stable position. That means it is null positive. Got it? The position null positive. What if that particular drug which we created is not, it is not having any differences? All right, that means it will become an alternative. Got it? So we have to change the testing, we have to change the medication. Clear, everybody? All right. Okay. Now this beta risk is contains the possibility of making an improper decision. Why improper decision? It can be a big risk to the consumer. When you're talking about medicine industry, medical industry, pharmaceutical industry, if you do one small error, it can have a biggest consumer risk. All right. I gave one example. There was one of the other delegates in the last year batch. He used to work with a pharmaceutical company, the eye drops company. There was a human, this eyelashes in one of the unit of it. It's a European Shenzhen-based country-based company, and they had, and this was a subsidiary branch in India. They have now made a big state, and that this might come in the news as well. It is now they've made a lawsuit complaint against the Indian branch, Indian manufacturing unit. Got everybody? Correct? So it was such a huge risk. People can lose their eyesight as well, isn't it? Correct? So if you're making any kind of improper decision about labor, manpower, hygiene, which can also directly can have a consumer risk, because consumers are the one who's consuming your product. Clear? Okay. Now, one important factor, large sample size tested, the smaller the better risk. You'll see the similar one, large sample size tested, the smaller the alpha risk. Correct? Why the statements are so simple? The statements are simple because if you collect larger sample size, you'll understand the in-depth of the root cause of a problem. If you want to know the obesity of the Indians, Indian citizen, we have to have a larger sample. Can we just only do for Mumbai region? Can we only do for the Hyderabad region? Will that justify the entire India? No, right? Correct? So it's always better to have the entire population. That means it's always better to have a survey done on the entire citizen rather than one region. Clear? All right. So larger the sample size and the smaller the risk can be understood. Next slide. Kindly continue.
The possibility that a false hypothesis in a statistical test is accepted as true is represented by beta risk. In contrast, alpha risk assesses the likelihood that a null hypothesis will be rejected when it is truly true. A statistical test sample size can be increased to lessen beta risk. A 10% level of beta risk is considered acceptable. Over that, the sample size should be raised. Beta, which is part of the capital asset pricing model and gauges a security's relative volatility, is only tangentially related to beta risk in decision making.
Okay. Now, you have beta risk. It's also called as false hypothesis. All right, false hypothesis. Why it's false hypothesis? Because null was done as the first test. Correct? Correct. If null fails, that's why you do the alternative. Correct?
Yes.
That's why it's called as false hypothesis. Clear? Now, it is contracted. All right, a contradictory statement, then the alpha risk. So obviously, beta will be opposite to the alpha risk. Correct? And when the hypothesis is rejected, when it's actually true. As I gave an example, right? You are rejecting, but it was true. Cancer was working, but it was not diminishing. It was just helping to not to progress. Correct? So cancer, that particular drug was working, but it was not giving a fully stable condition to that. That's why it was rejected. Got it now? So this sample test can increase to the lesson by the beta risk. So as I said, under null, it should be 0 and nothing but the 0. And in the beta risk, it all starts from the 0.1, it goes up to the 10%. Got it? From 0.01 to the 10%. That is beta risk. All right. If in your result, it comes any of this 0.1 to 10, that means your company facing a beta risk. And if the company have 0, that means your company is very good to do. And your company have a defect-free manufacturing process, and you have a null hypothesis result. Clear?